रब्बि इश्रह ली सदरी व यस्सिर ली अमरी वहलुल उक़दतम मिन लिसानी यफ़क़हू क़ौली अऊज़ु बिल्लाहि मिनश शैतानिर रजीम बिस्मिल्लाहिर रहमानिर रहीम अल्लाहुम्मा सल्लि अला मुहम्मद व अला आलि मुहम्मद कमा सल्लैता अला इब्राहीम व अला आलि इब्राहीम इन्नका हमीदुम मजीद. Guys, in this video I will do the proof of Fayaz Tahir series expansion of functions. Fx is equal to fb plus x minus b f prime x minus b whole square over 2 factorial f2x plus blah blah blah. Okay, for this I will use Fayaz Tahir fundamental theorem of calculus. Okay guys, this is not the fundamental theorem of calculus given in textbooks or Wikipedia. This is a different version of it called Fayaz Tahir fundamental theorem of calculus. FT as below. FB, capital FB minus capital Fx is equal to integral of small fx dx. Fayaz Tahir fundamental theorem of calculus. Okay, apply FTC to the integrand f1 t1. Just replace x by t1 temporarily. Okay, so FB minus Fx is equal to f1 t1 dt1. Here you have fx, here you have f1x. So what comes before f1 is f, okay, small f. So fb minus fx is equal to this. So similarly, transposing fx on the right hand side, we get this one. Apply ftc again to the integrand f2 t2. So f2 t2 is the one power derivative less f1 t1 is equal to f1x, like this one, plus so after substitution fb is equal to fx plus fb minus x f prime x. When we integrate this term, when we substitute this one here and integrate, we get x, and then we put the limit x to b, we get b minus x f prime x plus blah blah blah. So repeating the ftc step again, I obtain as below. f2t, so 3, 1 derivative less 2. After substitution we get this term b minus x whole square over 2. When we integrate this one and put the we get this one b minus x square over 2 factorial plus blah blah blah. So separating fx, I obtain as follows. Fx is equal to fb plus x minus blah blah blah. In compacted form we can write it as with the remainder, where the nth order remainder is the n plus 1 times the repeated integral. So the remainder is this. So we have the Tahir series expansion of function as below. Fx is equal to fb. Guys, don't worry about the remainder, it's not that important. Okay, so we have the Tahir series expansion of function as below. Fx is equal to fb in the compacted form using k. So guys, k should not be considered the level of truncation. Why? Because k has nothing to do with mathematics and its philosophy. It's just a tool to write a long expression in a compacted form. So please don't focus on k. K is just a tool. It has nothing to do with the concepts of mathematics. Okay, just a tool to write in a compacted form a long expression. So here you have the Fayaz Tahir series expansion of functions. Fx is equal to fb plus x minus b blah blah blah. So guys, when we compare this series with Taylor series, we see evidently that this series contains conceptually more information than Taylor series. Why? Because Taylor series does not contain derivatives at the arbitrary point. It contains the derivatives at the center point, b, a. In the Taylor series they take a, but here in my the Fayaz Tahir series expansion of functions, I have considered the fixed point as b. I mean the x coordinate of that point, x is equal to b. Okay, so this series has got more interior information of the function, and this series also say that the information of the function value is hidden in the information of the derivatives at that point of the function, which is very important, and it's going to make a big difference. Okay, so fx is equal to blah blah blah. The above is the Tahir series expansion of function of all arbitrary points. AP is about a central point CP whose x coordinate is b. So we can In order to understand Fayaz Tahir series expansion of function, we can write it as f at arbitrary point is equal to f at center point plus arbitrary point minus center point, central point, arbitrary, blah blah blah. So you can understand this easily. Why I write it like this? So that when in my next video, not in my next, after that, in my second next video, when we find the most accurate quadrature formula in human history that will beat all other quadrature formulas, we will apply the concept of Fayaz Tahir series expansion of function so that you can understand it in a better fashion. So that you can get ready for my incoming video in order to see the finest, not the finest, the most accurate quadrature formula in human history. Okay, but my next video is gonna be on another proof, a little bit more delicate than the one that I've shown in this video. Just wait till I publish the next video. Subhanallah walhamdulillah wala ilaha illallah wallahu akbar wala hawla wala quwwata illa billahi al-aliyyil azim. Kul huwallahu ahad Allahu samad lam yalid walam yulad walam yakul lahu kufuwan ahad. Thanks for watching.